Hello, welcome to the fifth part of carbohydrates. So in the previous two videos, we saw about two major monosaccharides, that was glucose and fructose. And in today's video, we'll be seeing about how we can convert glucose to fructose and vice versa, that is fructose back to glucose. So the first conversion we are going to see is a conversion of glucose to fructose. For this, let's draw the structure of glucose that we already learned. Glucose has an aldehydic unit, so there's a CHO group, right? Followed by a CHOH unit, followed by CHOH again, and this occurs 3 times. It keeps repeating, and finally at the end we have a CH2OH unit, primary alcohol. This is the structure of glucose we learned. So the first step for conversion to fructose is we have to make this glucose molecule to undergo oxazone reaction, and oxazone should be formed. That is, we treat this with phenylhydrazine, and 3 parts of phenylhydrazine is to be treated with 1 part of glucose to form the oxazone. That is 3 times C6H5NH2, right? This is phenylhydrazine. Upon treating with glucose, this aldehydic unit gets converted to CH double bond N NH C6H5. The second CHOH also gets converted to C double bond N NH C6H5. Right. The rest of it remains the same as CHOH 3 times and CH2OH at the bottom. This is glucosazole that we get after the oxazone formation. And next thing that we do is we have to make this oxazone to undergo acidic hydrolysis. So for that, we treat this with H2O / acidic medium, so H+. So what happens is, the topmost part, the first carbon, gets converted to aldehyde, that is CHO. And the second carbon, the double bonded carbon, that gets converted to ketone. And the third and the fourth group, they remain the same, that is CHOH 3 times and CH2OH. These remain the same. Now, the final step for conversion of glucose to fructose is the reduction of this molecule that is formed after acidic hydrolysis. This on reduction. So for reduction, I'm using zinc dust and acetic acid. So I treat this molecule that I got with zinc dust and acetic acid. So when I do that, this aldehydic group gets reduced to a primary alcohol. That is, at the first position, I will have CH2OH. The ketonic part, the second carbon, remains as ketone. Third, fourth and fifth CH remains as CHOH only 3 times. And finally, the sixth carbon remains itself as CH2OH. And this is the fructose unit. So, this is the 3-step process for converting glucose to fructose. And initially, we started with glucose. We got glucosazone. And the final product we got was fructose. Clear? So now the second and last part of today's video is the conversion of fructose back to glucose. For this, we'll take a fructose unit. This is a fructose molecule where we have a primary alcohol at the top, followed by a ketonic group at the second position. C2 is ketonic group, followed by 3 CHOH units, and finally we had the 6th carbon atom, we have the primary alcohol CH2OH. First step is we have to treat this with sodium amalgam, that is reduction using sodium amalgam. NaHg reduction. Sodium amalgam treat and cause the reduction of fructose unit. So what happens is, upon reduction, the carbonyl group or the ketonic group at the second position gets converted to alcoholic units. So first carbon remains as CH2OH, followed by ketonic group changes to CHOH, and remaining portions remain the same. That is CHOH. Again, the fourth carbon is CHOH. Fifth is CHOH. And finally, at the sixth position, we have CH2OH. This is the product obtained after reduction of fructose. And the next thing is, we have to make this to undergo oxidation with HNO3. Treatment with HNO3. When you treat this reduced product with HNO3, what happens is, this group at the top, the CH2OH, gets converted to an acid. So, this becomes COOH. There is CHOH. Then there is CHOH. 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 1, 2, 3, 4, 5. And the sixth one is CH2OH. It is just the first CH2OH that converts to acid. The next step, we are heating this. So, upon heating, what happens is, water molecule goes off, leading to the formation of a gamma lactone. So, which is the gamma lactone means this here at this position. Alpha, beta, gamma. This is the position where the lactone would be formed. So, we can say that we get something like C double bond O, CHOH, CHOH, and at the next carbon there is CH, followed by another CHOH, and finally the CH2OH. Here, the gamma lactone is being formed, and in the last step, we again treat this with sodium amalgam. When I treat this with sodium amalgam, finally I started with sodium amalgam, I end with sodium amalgam. I'm treating. What happens is the lactone opens up and that gets converted to an aldehydic unit. So we have CHO, CHOH. Then the next one is CHOH. Then the gamma one, that also gets converted to CHOH. Then there is one more CHOH. And finally the CH2OH unit. Clear? So we can say that, and this is the glucose. 1, 2, 3, 4, 5, 6 carbon atoms. Aldehyde at the first carbon. Remaining all are alcohol units, and the last one is primary alcohol. So we started with the fructose unit. We went on to form a gamma lactone, and finally we got a glucose. So this is the conversion of fructose to glucose, and these were the two reactions that we dealt in this particular video. That's it for today. Thank you so much.